If I should stay on task, I would get my homework done today. But I will always be doing my homework. And this problem specifically, let's go back to it. We are still working on it and we are not done yet. If you recall, we were talking about surveying people, asking them whether they are male or female, and do they like vanilla, chocolate, cookie dough, or sherbet ice cream. So what I want to do now is, based on the null hypothesis, where the null says they are independent, meaning there's no relationship, can I get the values that I would expect? So I'm going to make a whole new table. This table has a name. It's called observed table. See how it says, you can't see that because my head's in the way. See how it says observed? Now I'm going to make a whole table called expected values, like this. So I want to find the number of males and females for each of these categories, vanilla, chocolate, cookie dough, and sherbet. And I want the totals to be the same. 18, 40, 86, 22, right? And it should add up to still 166. But the number right here, instead of 10, I want to ask myself, how many should be right here if it was independent? So if it's independent, we're going to start with what we had before. Do you remember this from the last video? Where we found that under independence, we can split those probabilities into two multiplication probabilities, and this turned out to be 0.0627. So if it was independent, out of these 166 people, 0.0627 of them should have been males that are vanilla. So how do we find out the number? Well, if I take this probability and I times it by 166, I get 10.4. Almost what we observed is 10. Now, some of you may be concerned that you can't have 0.4 of a person without going to jail for cutting people up, but that doesn't matter because averages could land in the space where you can have, right? Number of average kids in America is 2.7. So this is working way in averages. 10.4 is what we expect. We observed 10, really, really close. Could it be that the null hypothesis is true in this case? Well, that's only one cell. Let's do it for the chocolate men. Ready? It would look like this. We would do the probability of being male, the probability of preferring chocolate ice cream. There's your two probabilities right there. Times it by the 166. Now, many of you math people out there are saying, you could simplify this, just cancel those out. Yeah, I know, I get it. What do you get from this? You get 22.4. So let's put that up in our chart right here, 22.4, and compare. How does it look right here? Wow, really, really good. It seems like the null hypothesis could be reasonable because we're getting data very close to what the null hypothesis said we should be getting. Let's try the next one. This is cookie dough. The best ice cream of all gets the probability of being male times cookie dough, 93 over 166. That's how many males. Cookie dough is 86 out of 166. And now to find out the number of people, I'm going to take that probability times the 166. I probably shouldn't have equals there anymore because I've changed it from just probability to count. So here, I'll put some notation. Don't tell your math teacher. I'm sure there's some special sign that's supposed to go there, and they're mad at me right now. We can cancel those out, and 93 times 86 over 166, let me do that in my head, is 48.18. 48.18. I'm going to put that here where it goes, and ooh, not as close. It turns out we were only supposed to have about 48 men who love cookie dough. We've got 54. Maybe the null hypothesis is not true. For vanilla and chocolate, it doesn't seem like there's that big of a difference, but for cookie dough, it seems like we have more men who like cookie dough than they should. So now let's go to sherbet. But have you noticed something? I know it adds up to 93. Do I actually have to calculate this one out? Well, I'm going to do it anyway because it's good for us. But it should add up to 93 if I do it right. Survey says, and we have 12.3 as the expected number of sherbet, which goes right here, and it does indeed add up to 93, just the way it was supposed to. Actually, clever eagle-eyed people will notice I rounded this one to match the rounding on the others, and I kind of messed up right there. It's 10.1, not 10.4, so yeah, sorry about that. Actually, knowing it didn't add up to 93 gave me a clue, and I went back through and spent, you have no idea how long, because the video was paused, but the point is, now it adds up to 93 and it's right, and I can check it. So let's do these others. In your mind, you might be thinking, you don't have to, just take 18 minus that one. You know what, I'm gonna do it anyway because it's good for me, and it'll take you all of 5 seconds. Watch, ready? 1, 2, 3, 4, 5. Now let's take just a second and appreciate what we have here. These expected values are what the null hypothesis said we should get. 7.9 to 8, really close. To 17.6 to 18, that was close. But here we expected 37, we only got 32. So we thought we would have more women who like cookie dough. They don't seem to be. It seems to be that we have a lot of women moving to sure, but what is wrong with you? So let's write down, how do we get these expected values? This expected values table. Our expected values are the row total times the column total divided by the table total. I sound like a cereal commercial. Now, what happened to the other table total? Well, there used to be row over total, column over total, times total, but those canceled out. You saw how I was canceling it out every single time. So now let's just leave it canceled out. To get this guy, 93/18 over 166. To get this guy, 73 times 86 over 166. That gives us our expected values. This guy is kind of like our mu. He's what the null hypothesis said we were supposed to get. This guy is kind of like our x bar. He's from the data, what did we observe? So now on the next video, we're going to talk about how do we compare x bar against mu.